Roll.
So, hello students, my name is Krishnendra Mukherjee and I am going to teach the subject of physics. Now, we already know by now that the earth is spherical in shape or slightly flattened at the top and the bottom, just like the shape of an egg. Now, the question comes that we had actually the battle of science was not so easy, because in the previous days the earth was considered to be rectangular or square in shape or to be quadrilateral in shape, but by now we are in a comfortable position, and by the scientific inventions or invasions, whatever we say, we are in a comfortable position to say that the earth is spherical in shape. Now, standing on any point on the surface of the earth, if we throw any body upwards, the body is bound to fall downwards. That means towards the ground. Okay? Not only so, even if we are suppose playing football and we are kicking a football, we are giving a force like this, a velocity like this, a force like this, the football does not fly off to the sky, but it comes back maintaining this kind of a path. So, it means that there is a central strong force that is attracting any body towards its center or towards the center of the earth. Now, we obviously know that there was a great scientist, or whatever we say, a physics researcher, a physics scholar, whatever we say, whose name was Isaac Newton, who was sitting beneath an apple tree, and suddenly an apple had actually, he saw the apple, it was falling downwards and it had hit his head, and by that he thought that why that apple is not flying off and it is falling over his head, and by that it is supposed that there is a story that by it he created or he invented, whatever we say, he discovered the gravitational force. So, by this we know that we are going to learn the topic of gravitation today. So, what is gravitation? Gravitation is a force which attracts any body towards the center of that planet. So, our topic of discussion is gravitation. Okay. So, there is a strong force which attracts any body towards the center of the earth or any planet. That force is known as gravitational force. So, as Newton had discovered this gravitational force or the theory of this gravitational force, he had given a law of gravitation by which we are going to start. The theory starts. So, Newton's law of gravitation, it says that suppose we are having two masses m1 and mass m2. And the two bodies are separated by a distance r. So, the gravitational force, let me tell you the law first. The law does not contain the word of gravitation. What it says? Every two particles attract each other with a force which is directly proportional, which is directly proportional to the product of their masses, inversely proportional to the square of the distance between them, The law does not stop here. Let me tell you, as it is a force, it is bound to have a direction. So, the law continues that, and the force acts along the straight line joining the two masses. So, F is directly proportional to m1 m2 by r square, and the direction is along the center of the two masses. Okay. So, as it is a variation, it is bound that we need a proportionality constant to complete this variation or to convert this variation in the equation. So, F equal to G m1 m2 by r square, where r is the distance between m1 and m2. So, this capital G is known as universal gravitational constant. I repeat, universal gravitational constant. Okay. So, how we are going to, or how do we know that this law is right or this law is wrong? Suppose you are throwing two bodies from the same height of two different masses. Now, the earth, it has a mass, and I have this pen and I have a metallic ball. Which will affect the earth or which will affect the ground more? Obviously, the metallic ball, because it has a greater mass. So, this force is greater for greater masses and smaller for smaller masses. What will be the unit and value of capital G? We are only going to deal with the SI units. At first, let me tell you what will be the unit of capital G. How we are going to find units? See, capital G equal to F r square by F r square by m1 m2. So, how we are going to find out this unit? See, G's unit will be Newton, the unit of force is Newton, meter square per kg square. Okay. The SI unit is Newton meter square per kg square, and the CGS unit will obviously be dyne centimeter square per gram square. We are going to learn about the SI unit. The SI unit or the SI value of capital G is 6.67 into 10 to the power of minus 11 Newton meter square per kg square. This is all about Newton's law of gravitation. Now, the chapter does not end here, because we have more topics to cover. So, okay. Now, the intensity with which a body falls is known as acceleration due to gravity. We had learnt about, we had dealt with the acceleration due to the concept of acceleration due to gravity. We had used it in the chapter of motion in doing v square equal to u square plus 2as if the body is falling from a height h above the surface of the earth. So, we are going to write it v square equal to u square plus 2gh. By that we know that g is acceleration due to gravity. Now what is g? How we are going to find out g? For that we need some attention. So pay attention and you will know about the concept of acceleration due to gravity or the gravitational field intensity. Both are the same thing. Whether you deal about gravitational field intensity or you say that it is acceleration due to gravity, they both are the same thing. So weight of a body is nothing but, see, just think, what is weight? Weight of a body is the force with which a body falls from a height above the surface of the earth. What is gravitational force? It is also something related to gravitation. So both will be equated and both are equal in, both must be equal in their own values. So mg, a body of mass capital M, of mass small m, a body of mass small m is being attracted by the earth which is of mass capital M, or any planet of mass capital M. Okay. This is small m and the earth is capital M. So the force with which this mass small m is attracted towards the center of the earth is g m m by r square, where r is the distance between this mass and the center of the earth. This is equal to mg. So this mass gets cancelled, therefore small g equal to g m by r square. This is the mathematical expression for acceleration due to gravity. Now this acceleration due to gravity will have various values for various surfaces. How we are going to know that? Now think very carefully. Suppose a body is on the surface of the earth and a body is at a height above the surface of the earth. This is height h and this is the radius of the earth. So the distance between the body and the center of the earth, which we tell to be smaller, is equal to capital R plus h. And a body which is on the surface of the earth, it is at no height but it is on the surface of the earth. So the body is a distance small r from the surface of the earth. So this is our base value. Acceleration due to gravity on the surface of the earth will be mg equal to g m m by r square, because the body is at a distance capital R, the body which is of mass small m and the earth is of mass capital M, the body is at a distance capital R from the center of the earth. So this small m gets cancelled out. So the acceleration due to gravity on the surface of the earth, it is g m by r square, where capital R is the radius of the earth itself. But in this case, when the body is at a height h above the surface of the earth. So this comes to our first topic, where we are going to discuss about the variation of acceleration due to gravity with respect to various factors. So the force factor, this is the force factor, the variation of acceleration due to gravity to height, variation of acceleration due to gravity due to height. Okay. So, a body is at a height h above the surface of the earth. Okay. A body is at a height h above the surface of the earth. So, here in this case mg equal to g m by small r square, where small r is nothing but equal to capital R plus h. So, m gets cancelled, g equal to g m by r plus h whole square. Now, from here what was the originally the value of g m? Originally the value of g m was g into r square. We are going to put this value g m equal to g r square. So, g m equal to g r square in this equation, r square by r plus h whole square. Okay. So, small g equal to, we get g by r plus h by r whole square. Therefore, small g equal to g by